model. So what is this? Each object has an owner, or sometimes an object may have a shared ownership, or multiple users, subjects may be owner for an object. Okay, so now it's the owners who can decide who are like what the others who are not the owners, okay, what permissions they have on the object. So if you work with Unix, this will be very straightforward. Okay. So typically you have three permissions that you want to always set and control: the read permission, write permission, execute permission. Okay. So now let's just quickly go on the Unix point of view. So have you used the chmod? Mostly everyone will use the chmod command, right, to change the permissions on the file. So you can typically use this only and to change permissions on your own file if you are owner of that file. Okay. So there are three sets of users: the owner of the file, the group to which the owner belongs to, and others means everybody except outside the group. Okay. So you can have read, write, execute permissions for each of them. Okay, for the file. So let's say you want to change the permissions on the file. So it's a file, say a.text, and as I mentioned here, you want to set up the read, write, execute permission to its owner, read, execute only permission to the group, and read only permission to others. Okay. So the way it is done is, as you see here, it is, if at all you set all the three, it is given as listed as RWX, right? So the way it's implemented is 3 bits. Okay. So this is the least significant bit, this is the most significant bit, and it's an exponent of 2, 1, 2, 4, right? So that's why the read bit has a weight of 4, the write bit has a weight of 2, and the execute bit has a weight of 1. Okay? So if I want to set like what I have there, read, write, execute for the owner, and read, execute only for others, for the group, and like that. Here we basically need all, right? So 4 plus 2 plus 1, so that is going to be 7 for the owners. And then read and execute. So read is 4, execute is 1. So 4 plus 1, 5 for group, and then read only for others. So it is 4. So when you do the chmod command, how would you run it? Chmod 754 a.text. So if you created a file a.text and you want to change permissions like this, you would pass the numbers like this. So the first one indicates for owner, and this indicates for what? Group, and the third one indicates others. And you know from again digital logic or any architecture course, an integer can represent only uniquely in binary, right? So 7 means it is what? 1, 1, 1. So all the 3 bits are set, so that's what it means. So the owner gets, the 3 bits are set for the owner, so the read bit, write bit, execute bit. 5 is 1, 0, 1, right? So the read and execute bits are set for the group. 4 is 1, 0, 0, so it's only the read bit is set for others. Okay, so you can do a lot of, as a second example, you want to set the read and write permission and execute permission to the owner, read and write permission to the group, the same thing now, and no permission to others. So read, write, execute means you want all the 3, so 1, 1, 1, so that is 7, right? Read bit is 4, write is 2, and execute is 1. So always remember that. Okay? So read is RWX. So then 1 to 4 we wait in binary. Okay? And read and write for others, for the group. So read and write for the group means what? 1, 1, 0, right? Read, write, execute, read and write, and no execute. So 1, 1, 0, so that is 6. And no permission, nothing for others, so it's all zeros. So that's going to be 0 for others. So the way you will do that is chmod 760 a.text. Okay? So don't read it like 760 or something. Each integer having its own significance. Okay? Any question? There could be a very small question like this. Let's look at the question then.
Can you repeat one more time the 766?
7.
60 for each one, so that's 7.
7 is the first integer always represents what? The user, the owner.
The owner, yeah,
The second integer represents the group, and third one represents others.
But each one we have to have to.
Each one is 3 bits.
3 bits, okay.
So if you want to set read, write, execute for the owner, set all the 3 bits to 1. So if you set all the 3 bits to 1, it is. If you set all the 3 bits to 1, it is 7. If you set only the read and write, it is 6. If you set only read and execute, it is 5. Okay?
What is CH?
chmod, that's the name of the command. Change, I don't know what the mod stands for. Mod, you know, everybody knows? chmod, I don't know, maybe you can repeat it. There's another command, chown, that is probably a super user, administrator. This is used to change ownership of an object. So if you're a super user or administrator, that person can change the ownership from one user to another user. A regular user cannot use ownership to another user. You cannot do that. A super user can do that. Or admin of the root. Okay. There's also a setuid bit involved here, which I don't want to go through now. Maybe later when you look at program security, we'll go through that. Now, like files, you also have permissions for folders in Unix especially. Okay. So, like files, you can have read permission, write permission, and execute permission for your folders. The read permission for a folder is needed to list the contents of the folder. If you use ls command, list command, in order for you to run and see the contents of a folder, you need to have the read permission in that folder. And write permission, if you want to create any new file in that folder, you have to have a write permission to that folder. And execute permission, you need to really change your current working directory to that folder. So for example, sometimes I may say, like as I have here, there's user Bob, and then there is a file in the home directory of another user Alice.
They say change mode.
Huh?
Change mode.
Change mode, yeah. That's what I thought, yeah. So, so Alice wants Bob to have what? To be able to read this file. So, what do you think Alice should do? And Bob, let's say, belongs to others, right? So she should first do a change mod command on that readme.txt file and make sure whatever the first 2 bits, it doesn't matter, but make sure the last one is at least 4, right? Because we want Bob to be able to read. So you say readme.txt, the name of the file. But this is not sufficient. Why? Bob has his own directory. He belongs to this directory. This is his home account. So from here, he wants to be able to read that file, Alice account, right? So what should Alice do? In addition to giving the read permission to others for that file, she should also give what? The execute permission for the Alice folder, right? So the whole thing, if you look at the hierarchy, the home, and you have Bob, or you have users, home user, and then you have Bob over here and Alice over here. And Alice has a readme.txt file. So you want Bob should be able to get to this folder Alice and then be able to access that file. So it's not only enough to give the read permission to this file, you should be able to let Bob to change his working directory to this Alice folder. So which means you can run again a chmod on the directory now or of the folder. Okay? So now this is again Bob is others, right? So you have to say chmod what? Whatever you want to give for the owner and the group, make sure he's able to at least execute. So 1. Right? So then the folder name is Alice itself, so just say Alice. If you have the same folder, probably press a dot or put a dot over here. So you can put a dot here, that means the current folder that you want to give permission to. Okay? Now normally you don't want to give write permission to others, right? So that they can come and change the file. So it's just sufficient to give execute permission to others. Okay? So these are things we can play by logging into Red Hat 3. We all have accounts there, so it's very important to know some basic Unix commands. Now, what is the problem with this discretionary access control model? As I said, each owner or owner of an object has the authority to set permissions for others, right? So I may know someone who belongs to the others category, so I may want to give all the 3 permissions, read, write, execute to that person on a particular file which I own. But as an organization policy, the organization doesn't want its users to give, say, the write permission to others. Okay? So the owners should not give write permission to others. That's the kind of organization policy. But I want someone who I know very well, I know that they're not going to do anything bad, so I give them the right permission and they belong to others. So it's a conflict of interest in the sense that I want to do something but my organization doesn't allow. Right? So it's very difficult to enforce uniformity because here the owner or the person who owns the object has the complete authority to set permissions on the objects they own. So the organization cannot enforce uniformity across all users. So that's why this is not really a preferred model in a kind of a secure environment. If you go to all the defense organizations, they don't implement this model. They mostly implement a mandatory access control model where each user the users are classified into different security levels, top secret, secret, classified, unclassified, and all those things. And then we see that model a little later. Okay? And also if there's a shared object, so which means an object is owned by more than one user. Okay? So like a scenario I explained here, you could have a kind of a dangling pointer kind of problem where there are 2 subjects who own an object. Okay? So S1 gives, say, some permission to S3 on this object. Okay? And S2 also gives some permission to S3 on the object. Say both of them say give the right permission to the object. Alright? Now S1 may revoke that permission after a while. So S3 doesn't have the right permission on the object. So S1 thinks its object is secure because it revoked the right permission on that object for S3. But the other owner, the shared owner, might have given the permission to write the object for S3. So S3 can still access the object through the permission given by S2. So when you have a shared environment like that, it is not possible, okay, to enforce again uniformity. So that's another problem with discretionary access control model. Okay. So any question? So now let's move on to the dynamic access control model. Let's see how much you can cover. So here the issue is, as I said, in the beginning, before you really log into the system, you have access to all objects out there. But once you access some objects, then which other objects you can access depends on what you have already accessed. Okay, so it's like again the Chinese wall model, as I said. As long as you stand on the top of the wall, you can jump either direction, either way. But once you go to one side, you cannot go to the other side. Okay, so it's implemented based on this conflict of interest idea. Okay, and I have a simple example to illustrate that. Say there are 3 kinds of companies, say oil companies, car companies, and pharmacy companies. and you know there are three different things, right? They don't have any conflict of interest between each other. An oil company may not be interested in anything about a car company, and the car company may not be interested in about a pharmacy company, right? But within oil companies, say you have three data sets, in the sense that consider them as three different oil companies, okay? Like that two different car companies, okay? And then three different pharmacy companies. Now they have a conflict of interest within each other, right? So if, say for example, you join as an employee of one oil company, say A, okay, the one prefix here stands for oil company, 2 for car, and 3 for pharmacy, and then A, B, C for the individual companies, okay, in that category. So if you join as an employee of one oil company, you cannot join as an employee of another oil company, because you may leak out some secrets from one company to another company. But if you are allowed to work on multiple jobs, you can join one oil company, and you can join one of the car companies and one of the pharmacy companies, right? So with this analogy, so let's say at the time of login, you can access any object. Okay, so now let's say each one is a data set, and each data set has some small objects. Okay, so you can access any data set and the object within the data set. So now let's say you accessed 1A. Okay, so let's say you read 1A. So you read an object from 1A. Since you read an object from 1A, you cannot read any other object in the category 1, the conflict of interest 1. So you cannot read anything from here, or you cannot read anything from here. Okay? So dynamically it is set. If you read anything from 1B, then you cannot read anything from 1A or 1C. So which set you can access depends on what you have already accessed. Okay? So if you have, but if you have read say 1A and you want to read 2A, yes, of course you can go ahead and read 2A. But once you read 2A, you cannot read 2B. Okay? So that is the read model, okay, for the Chinese, or this is the Chinese wall model, but in general the dynamic access control model. Any question? So this is all the read, yes.
So you can read from oil company, and also can read.
Yes, you can read from multiple across. This is called conflict of interest. So you can read one this and one of this and so on, but you cannot read more than one data set within the same conflict of interest. Okay. To start with, you can read anything, but once you read something, you cannot read something else within the same conflict of interest. So this is for the read permission. Now what about write? Which means you want to write to say, say an object over here. You think you can write an object or copy an object from here and write it over here? No, it's again a conflict of interest, right? Because you first of all don't have a read permission, right? So to be able to write something, you first check for the read permission, alright? So that's a basic requirement. So if I want to write an object from 1A, copy it from 1A and write it to the data set 1B, I cannot do that. Why? Because since I have read 1A, I cannot even read 1B. So you cannot write to 1B, right? And the write permission is even more strict in the sense that, let's say you have read 1A and you have also read 2A. So just to read, you can read both the data sets. Now if you want to write, you cannot write even across the conflict of interest. It's more strict. Okay? So what you can write to? You can write to only to the data set that you read the first time, the first data set that you read after logging into your system. Which means if you read this set, you cannot write to any other data set. So which is very restrictive, and I'll tell you how it can be fixed. So the default model is you can write only to the data set that you read the first time. and you cannot write to any other data set. So if you want to have write permission, or if you want to write to something, you better read that data set that you want to write to. You don't read any other data set for that session. Okay? Now what's the question?
Okay, so you said if you don't have read access, you cannot write.
Yes.
Okay, my question is, it doesn't really apply to just this slide. It's like my question in general. So if you don't have read access to a file, can't you write to it? Like for example, when you're filling out surveys online, you type in your answer and post to the database, but you can't see what others. You can see it,
So that's different. So for this model, yes, you have to, the way they are formulated is, in order to check whether you have write permission on an object, you want to have read permission. So if you look at the rules, that's what it would say. I understand what you are telling. You could have write permission without the read permission. It's close. So it is very restricted.
Do they have a virus that makes it keep doing that?
I don't think it's a virus, it's a memory problem. I'm actually thinking we'll better move to the 212 classroom from next time.
You slowly getting back to your old classroom?
Yes, I like, not the other one, the